So I can see that has computer chips, and they find that 8% of all of the computer chips are defective. And so basically they want to lower this defective rate because they think employee inattention is responsible for this high defect rate. So in an attempt to reduce the percentage of defects, they're going to have an incentive program for employees. And they're going to try this for 1 month and see if this significantly reduces the rate of defective chips. All right, so we want to do our null and our alternative hypothesis. And so we'll write that the null, but we probably need to define that P is the proportion of what? Okay, so P is going to be the proportion of the chips that are defective. And so it's in the whole company. They're seeing if the proportion of the chips in the whole company that are defective is what proportion that is. And so then our null, of course, is that it is maintaining at 8%. Okay? And so then our alternative is what they're, in this case, wanting to achieve, and that's to see if the proportion has decreased. Okay. All right. So in this context, describe a type 1 error. Okay, so type 1 error. If the null is really true, but you find a sample that causes you to reject the null, that's a type 1 error. So let's see. You would then say that the proportion is maintaining at 8%. So we'll say the P is still 0.08, okay, but we got a sample to make us think that P is less than 0.08. And so then what's a consequence of that? You know, we lose money. The company would lose money on incentives that do not really work. All right. Now we're going to describe type 2 error. Okay, so our type 2 error is going to be that, let's see, no evidence. We got no evidence. So what we do is we fail to reject a false null hypothesis. Type 2 error, type 2 error. We fail to reject a false null hypothesis. All right, so we failed to reject a false null hypothesis. That means that the defects are less than 8%. So the program's working. So the defects, the proportion of defects is less than 0.08. So in other words, the incentive program is working, but we do not detect that. Okay, so what happens is then we we would quit the incentive program. So we would end up stopping the incentive program when it actually works. Okay, stop the incentive program when it actually works. All right. Okay, now, based on the data that they collected, what they found was that a 95% confidence interval gave them, so 95% confidence, gave them this 5% to 7% interval. So the question is then, what conclusion should they come out with? Well, what happens is, since the 8% is completely, is not inside this interval. So since the entire interval is below the 8%, it appears as though the defect rate has lowered.
Is there anything I can do to help?
All right, so now let's talk about this level of significance. So this level of significance is essentially, what is the size of your rejection region? Okay, and if it's two-tail, then you have your alpha. If you're just doing one tail, then it's your alpha over 2. Technically, it's alpha divided by 2. So, and what I mean by that is this. When you have this 95% confidence, okay, then you got your 95% confidence in here in the middle. All right, then that, of course, puts 2.5% in each one of these tails. Well, since this, and I was a little confused on this yesterday in class, but I got it established, and so this is the correct thing, is that when they tell you this 95% confidence, that is that section in the middle, okay, which then puts your 2.5% on each edge. Well, your level of significance is the rejection region, and since this is one tail, then this lower 2.5% is your, it's technically alpha over 2, but, we use the alpha to also represent that rejection region, which is 2.5%. So that's what's going on this, is that our rejection region, our level of significance, is that one lower tail of 2.5%. Now, describe to management an advantage and disadvantage of using 1% alpha level. Well, let's think about that. So our alpha went down. The advantage, the way you want to break this up, is you want to say advantage is whenever an error went down. So the error that went down is type 1 error went down. Okay, so the type 1 decreased. A disadvantage is going to be the error that increased. So type 2 error increased. Also, power will go on this line, because if type 2 is increasing, then power is decreasing, and that's also a disadvantage. Okay, so power is decreasing. All right, so now on this next one, it says management decides to extend the incentive program so that the decision can be made on 3 months of data instead of the 1. So if we're doing 3 months of data, then what's happening is N is going up. And so if N is going up, then we know, based on our little drawing, remember our drawing, alpha 1, beta 2, and then N affects standard deviation, up and then down. These are ways that power increases. Okay, so if our N is going up, then our power will increase. Okay, our power will increase. And that's good. We like that our power increases, because that means if our null hypothesis is false, then we have more power to detect. So remember that power is the probability to reject the null if it is false indeed. So we can detect, we have a better ability to detect a false null hypothesis. All right. And the last one, over the trial month, 6% of the computer chip manufactured were defective. So they're saying that, for real, that the P is, in essence, 0.06. So it went down. Okay, so it went down. Now, management decided that this decrease was significant. Okay, so they rejected the null hypothesis of 8%, and they determined that the proportion is actually less. Okay, so they determined that it actually is less than the 8% previously. Now, why might they still choose to not permanently institute the incentive program? And so on this, you have to think of real life situations. You know, we have a benefit. We see that it has had a 2% decrease in defects. Why might I still not keep the employee incentive program going? And so the bottom line, as it is in many businesses, is money. And so the reality of what's happening is that the incentive program may cost more than the savings for the in the less defective chips. You know, maybe, sure, they're making less defective chips, it's just 2%, but the toasters or the vacations or the whatever it is that they're doing for incentives is costing them much more. All right, so that is your Chapter 21 warm-up key. Alpha level, then your alpha went from 2.5% down to 1%. Okay, so we made our little charts yesterday where we said, you know, alpha and type 1 error are the same thing, beta and the probability of a type 2 error are the same thing. N affects standard deviation, and if these go up, this goes down, but yet I see here my alpha is going down. So I want to fix this. I want to make the arrows go the other way. So let's go ahead and do that. Let's make this go down, which makes this go up. Okay? And these are the ways that power decreases, since this is down over here on the left. So this is the way that we're going to decrease power. All right.